We're revisiting slope here, so most of this should be review, but we're going to develop a little bit deeper understanding with our slope and our linear equations here. So first thing, remember, slope measures the steepness of a line. Always remember that rise over the run for slope. Okay, and remember, slope can be, when I have a line, find any 2 points on a line. So if I found like this point over here, any 2 points on the line, and then we subtract their y's on top and x's on bottom, right? So if I call this, we say this is like the first point, I'd say x1, comma, y1. And this is the second point, x2, comma, y2. Remember, for slope, we take their y's, subtract them on top, because that's the rise, right? And the x's, we subtract them on bottom. Well, if you start with the second point for your y's, you should start with the second point for your x's to be consistent. Okay, so on and so forth. So hopefully that's some review. And it's kind of confusing. Usually I'm used to having slope represented by the letter m, so m equals. But your book might use the letter B as well. And we're going to look at that in a second. So it's kind of confusing depending on which form you're looking at. Which I mean by right here. Slope-intercept form is what I'm used to, where y equals mx plus b, where m represents the slope. Remember, it's just the coefficient on x. And b represents the y-intercept. Basically what y is when x is 0. Whereas your book likes writing things in intercept form. And all it really does, we talked about this in the other day, is that it just flip-flops these two and gives them different variables. So it puts the y-intercept first and it calls it a. And it puts the slope times the x second and they call the slope b. Just know that the slope is always connected to the x. Right? The slope is always connected to the x. Whether they use m or b, it doesn't matter. You just got to get used to seeing it in different forms. So basically it's just like this. If I have the equation y equals, let's just say I had a slope of -3 and a y-intercept of 5. I could write it as y equals -3x plus 5. Or if I wrote it in intercept form, it would be y equals 5 minus 3x. It still means the same thing. They both have a y-intercept of 5, and they both have a slope of -3. Okay, you can just flip-flop them. So don't be confused about mx plus b or a plus bx. Just know that you have to basically just get y equal y by itself in order to have a linear equation to be able to tell things. So with variables, we have independent variables and dependent variables. And the best way to reference one from the other is to remember that the dependent depends on the independent. It depends on the independent. Okay, remember that. That's important. Okay, and we'll look at an example here in a second. So the dependent always depends on the independent. All right, we're also going to look at these words domain and range. Well, domain goes with independent variables, and the domain is basically all of our x values. Okay, so x values independent always goes on our x-axis. So if I were to graph anything, know that independent variables always go on the x-axis, right? Because we want to look, as the independent is increasing, we want to see what's happening to the dependent. Is it going up or is it going down? Right, so always have the independent variable on the x-axis, also known as the domain. Where the dependent, we call these values the range, and the range are just all of our y values. So domain, x's, range, y values, I just remember d comes before r, x comes before y. That helps me know which one goes with which. So domain with x's, range with y's. Well, let's take a look at a situation. Oh, and then obviously the range or the dependent variables always go on your y-axis. So let's just think of this. If you're running and we're looking at how far you go with your speed, which is the independent and which is the dependent? Well, I always just think, does how far you go depend on your speed, or does your speed depend on how far you go? Which makes more sense? Does how far you go depend on your speed, or does your speed depend on how far? Well, the first way, right? How far you go depends on your speed, right? You have to know how fast you're running before you know how far you can go. So how far you go depends. This guy depends on the other one. So how far you go is the dependent, where your speed would be the independent. So then if I were to graph these guys, that means I would have my speed on the bottom on the x, because that's my domain, that's my independent, and I'd have my distance on the y, right? So just think, which one depends on the other? That's how you remember. So how far you go depends, it's the dependent on your speed. So something you'll do in your assignment is finding the slope of the line. So number 2, and looking at E specifically, you want to find the slope. Well, can I just look and say, oh yeah, it's just the coefficient in front of the x. It's just 4.7. Is that correct? Not a chance. And why not? Well, you have to get it in your linear equation form. So I like using slope-intercept, so I need the y by itself, and I like having the x first. I like doing y equals mx plus b. So I'm going to deal with that mostly. Just get used to seeing it in both forms. So I just really have to get y by itself. Well, let's take a look. If I want the y by itself, that means I got to get this 3.2, this multiplied by 3.2 away from it, plus this 4.7x. Well, before I can deal with the 3.2, I got to move the x term to the other side. So to get rid of a positive 4.7x, I should subtract a 4.7x from this side to move it over. So whatever I do to one side, I do to the other. So they cancel each other, and I'm left with 3.2y equals, and since I like, well, first of all, are these like terms? No, one has an x, one doesn't, so I can't combine those two. I can't take 12.9 minus 4.7. And I like having the x term first because I like slope-intercept form, so I'm going to put negative 4.7x first, and then plus my 12.9. You could have those flip-flop. That's totally fine. I don't care. And lastly, to get the y by itself, we're multiplying by 3.2, so we should divide by 3.2. Whatever we do to one side, we do to the other. So they cancel, and y would equal. Remember, anytime you divide by a monomial, so one term, and you have multiple terms on top, I got 2 terms, I need to divide each of those by 3.2. So I should have negative 4.7x over 3.2. Plus 12.9 over 3.2. And let's go ahead and solve these two guys just to make it a little bit nicer looking. So I would get y equals, well, negative 4.7 divided by 3.2 is negative 1.46875. And plus 12.9 divided by 3.2 is 4.03125. So what is our slope now? Now I can look and tell that my slope is right here. It's the coefficient on x. So my slope is negative 1.46875. If I wanted to leave it as a fraction, the easiest way to do this is I could have went back to my old equation. If I multiply the top by 10 by moving the decimal out 1, I'd multiply the bottom by 10 by moving it out 1. So I could also say my slope is negative 47 over 32 as well. So I'm okay with either of those two answers. Just make sure that you have your equation in like a linear equation form, either slope-intercept or intercept. So let's look at one story problem here. So number 9, it says, this formula models Anita's salary for the last 7 years. U sub n equals 847n plus 17109. The variable n represents the number of years of experience she has. Okay, be careful with that. And U sub n represents her salary in dollars. All right, so first thing, what did she earn in the 5th year? And then what did she earn in her 1st year? So maybe let's do the 1st year first. Okay, so what did she earn in her 1st year? So be careful with that. In her 1st year, what would I plug in for n? So U sub n equals 847. Do I plug in 1? Be careful, what does n stand for? It represents number of years of experience. So in her 1st year, how much experience does she have? Oh, she'd have no experience, right? So n would equal 0 in the 1st year. She has 0 experience. So I take times 0 plus 17,109. So what was her salary? Well, U sub n would equal, that is just 0. So $17,109. Okay, so be careful there. So now when it asks, what did she earn in the 5th year? Well, how much experience does she have? Well, she has 4 years of experience going into her 5th year, right? So I'm going to plug in 4 for n instead. So just be careful with that. So 847 times 4 plus 17,109, which gives us 20,497. So always go back and reread your problem, right? Be very careful, okay? Always reread. Don't just assume. What else can we answer about this? Well, what is the rate of change in her salary? Well, take a look. Remember, rate of change is the same thing as slope. So what would the slope be in my equation, looking back up here? Yeah, like this is kind of your y, and this is really your x. So it's always the number that's in front of the x. So 846, basically going up $847 each year. So we'll say the rate of change is $847. And lastly, to ask, what is the first year Anita's salary will be more than $30,000? Well, what could I do with this $30,000? I could plug that into my equation. So I could put it in right up there. So u sub n, and now we could solve for n. Is 30,000 equals 847. We don't know n, and then plus 17,109. And so to solve, we would subtract our 17,109, and that would leave us with 12,891 equals 847n, and then we divide by 847 to give us 15.2. So be careful. So 15.2, what does that stand for? That's her years of experience. And what does it say? What is the first year Anita's salary will be more than $30,000? So she'll have 15 years experience. So technically, that's her 16th year, correct? So in her 16th year, because she'll already have 15 years experience, her salary would be more than $30,000. So just be careful on how it's worded. Okay, and take a look. And that's why having those explicit equations is helpful, because we can just plug things in and solve.